In the last video, I gave brief discussion on how to use RStudio, okay, how to create a new file, how to save it, how to find out, how to change the directory, okay, or the how to pull the folder. The next thing we want to do here is I want to continue from there, okay. So let us suppose that M is a data set, that is all these data set. You collected a data set and you find out those and you type those. You are not sorting them. Now, see, all these are the numbers, right? So sometimes you may have to deal with non-numerical data, for example, categorical data. I will show you that later, but first of all, I want to put this in a table, nice grouped table. Okay, how do I do that? Is if you run that, this is how you typed the data, right? C, and then inside the parenthesis, and then you separate them by comma. So what is the class of this data? Is numeric, meaning all the data set are numbers. Okay, now I want to table them, I want to group them, I want to put them in the group table. Okay, how do I do that? Is just table and then name of that data. So what does that mean? That means 1 is the X, and then these are the frequencies. Okay, 1 is repeated 4 times, 2 is repeated 5 times, 3 is repeated 3 times, and so on. See, 1 is repeated 4 times, 1 2 3 4, and then similarly 2 is repeated 1 2 3 4 5 times, and so on. Okay, so you can basically make the table of the frequency, I would say frequency distribution table, but it is not like a class 0 to 10, 10 to 20 like that, but it is like we call discrete frequency distribution table. Okay, so now let us deal about the categorical data. Okay, now look at this. So B, I give a name B equals to C, and look at this. We are writing like inside a quotation sign. This is for the categorical data. If the data is not numerical, we write them as a categorical data by covering them with the quotation sign. Okay, so if you do that, B, and then if you run that B, it is Randy, Nicole, and Adam, right? So I want to know what is the class. It is character. So it is not a number. It is just like a character, like a letter, or we call qualitative data, right? So it is not quantitative, it is a qualitative, it is categorical data. Okay, so if you sort this categorical data, it is just sort with the beginning alphabet, right? So A, N, and then R. That's what it does, sort by the initial. Okay, now let us, because in the elementary statistics we did the pie chart. Do you remember that pie chart? So how do I do the pie chart? Because pie chart is basically for the categorical data, right? So we will have a category and then the frequency for that category, and we used to denoted that by pie chart, right? So how do I do that? Let us see that. So C time is the call time. It is a categorical data. It has 3 different categories: day, night, and evening. Okay, that's the 3 different categories for the call time. And number of calls on the day, there are 3255, for the night 2429, and for evening 2890. So these are not categorical, these are the numerical data. That's why you don't need the quotation there, right? Again, if you are using your data, you should start with C and then the parenthesis there. Okay, now pi is the code for the pie chart, and then n calls is that n calls, that's the data, and label is C time, that's the label, and main is the title of that pie chart. Okay, let me run that one. What is it? Oh, by the way, I need to run from the beginning. Okay, so do that, the C time, you run the n calls, and then you do the pie chart. Look at this, it plots directly that pie chart. Okay, so this is the area for the day. This sector represents day, this sector represents evening, this sector represents night. Now suppose you want to write what percentage are these, what percentage are these, what percentage are these, like that. And also suppose you want to write different color, you don't like this color, suppose. Okay, you want to do the different color for that. So how would you do that? Is let us do that. So the first and second line are the same. Now we need to find out the percentage. What is the formula for percentage? Is round it. So we don't we want to round up. Okay, number of calls divided by sum of the number of calls times 100%, right? See, n calls divided by, that's how you find out the percentage, right? You find out the percentage, and c time is paste. This is the function we use, c time comma percentage. For the c time, you do c time and then the percentage. So you write the c time, the calling time, with, and we write with the percentage there. That's what we're writing here. That's a c time. And also c time paste, c time, we need to write that percentage symbol as well, separate, and then by that quotation mark. Now what you do is pi, number of calls, label is c time, okay, and the column name is color, col means the color, is rainbow, and then how many color in the rainbow, length of n calls. So how many n calls are there? 1, 2, 3. So you use 3 different colors, and this is the name. Okay, so let us do that. So let me do all those things. See, so it is picking the 3 different colors, and then the main is the title of that, right? And it is giving with the day and then space and then 38%, 28%, and 34%. It gives like that. Now I want to do the histogram. Do you guys remember that we did the histogram in the elementary statistics? It is the exactly same thing, only the thing is the function we use is the bar plot. Okay, bar plot. So all other things are same. Look at this. N calls is this, that the same data. Now the name of the n calls, this is how you do. Name of the n calls. So this name of this is day, the name of this is night, name of this is evening. That's what we did. And for this it is a categorical data, right? And bar plot n calls, LAS equals to 1, and space is 0, meaning that there is no space between the bar plots, and color is rainbow, right? Main is that. Okay, so I will tell you what is that LAS stands for. Okay, this is the bar plot with the color. If you said LAS equals to 0, what will happen there? Instead of 1, if you said that 0, okay, so this is how you represent the y coordinates, right? If there is 1, it does this way. So it is basically the way that you write the y, the numbers in the y axis. That's what it is. So whether do you want to write the horizontally or vertically, that's what it says. So 0 means horizontal, 0 means vertical, and 1 means horizontal. That's what it means. Okay, now I'm giving one more example. Look at this. So x is that values, right? X is that value, and the name of this is Richard has got 12, Minnie got 56, Albert got 33, Albert got 56, 67, and so on. Okay, so these are the name of X, and you are doing the bar plot there. Okay, it doesn't have any color there, right? Okay, so if you want to do the bar plot for the quantitative data, you need to write, these are the frequencies, these are the class. See, I'm giving you, you can write in the quotation mark, or we write just 1 comma there or 2 commas there, right? So this is what I'm doing. I'm giving the name and then doing the bar plot there. Okay, so you can do that way too. So here it is 50 to 60, 60 to 70, 70 to 80, and so on. All right, so this is how you can do the bar plot for the and the pie chart, okay, for quantitative and qualitative data. Let us see some more examples on creating a table for random numbers, and it will give you the bar plot as well. Okay, let us see that. So this is the random number generator, set seed, and then dice equals to sample of 1 through 6, 100 replace equals to true. What is it happening here is you are rolling a dice 100 times, and then dice has numbers between 1 and 6, including 1 and 6, right? So you are picking the number randomly in each trial. For example, in the first trial it will pick 6, in the second trial it may pick 1, third trial it may pick 6, and so on. Okay, it is, you are doing it 100 times, and then your dice will the outcome will be all these random values between 1 and 6, picking 100 times, right? Now we want to put this in the table. How? So I'm giving the name D table, dice table equals to table dice. So if you do that, oh, by the way, let me not select that. If you do that, then it will give you the the let me see one more time what is D tab means. So if you just if you just print that, it will give you the table of 1 is repeated 19 times here. See, 1 is repeated 19 times, and then 2 is repeated 15 times, 3 is repeated 18 times, and so on. Now I want to do the bar plot for that. Look at this. This is the bar plot. Okay, so you can draw the bar plot for any types of numbers there, like either it is quantitative or qualitative data. All types of data you can create bar plot. Okay guys, all right, let us go to the next thing, is the scatter plot. How do you do the scatter plot? So I want to first create the data. X equals to random norm. R norm means, what does that mean? That means it will pick 10 numbers. Okay, it will pick 10 numbers between let me tell this way. So R norm picks 10 numbers from a normal distribution. So the R norm randomly picks 10 numbers from a normal distribution with mean is 0 and sigma is 1. Okay, this is what it means. And then you can write like this. So it is like so R norm, so because X is basically normally distributed, right? So normal distributed with mean 0 and sigma 1. So you are picking 10 of them. 10 of them. Similarly, Y, the same thing. You are picking 10 of them and not normally distributed. So mean is 0, sigma is 1. Now, if you plot X and Y, it will give you, let us see that. So that's X, that's Y. I'm not showing you. So if you want to know how does the X look like and then Y look like, so these are the values around 0, right? So normally distributed 10 random values. Okay, so if you plot X and Y, so just plot X, Y. Okay, so this gives you like this, all the dots, -2, near -2 there is 1, all those X and Y, these are the X, these are the Y values. Okay guys, now if you do like, if you instead of just typing dots, if you type like type equals to, and inside the comma the apostrophe or whatever you say, if you do that, then run this, it will give you a line. So it will join all those lines. Okay, so join this with that, join this point with that point, with that point, with that point, and so on. So if you do type equals to L. Okay guys, all right, so now let us plot. Oh, by the way, I forgot to write the X, Y, all those values. Let us do this in a better looking way. Okay, so see, X and Y, we are plotting that. X level is 10 random values. Okay, Y level is 10 random values as well. X limit, meaning what are the smallest and biggest value of X you want to pick here. The smallest, we are picking the plot, we are plotting between -2 and 2 for X and between -2 and 2 for Y. Color is red, the color of the dots are red, and the main is how to customize a plot with R. That's what the title of the plot is. Okay, so let us talk about some of the built-in data set. Okay, what do you mean by built-in data set? So in the R library, there are already some data. For example, I can give you some example. For example, tooth growth data. So tooth growth data is already built-in data. The library has this stored in the library. Okay, so let us see what is that. Let me first remove this, clear this console, and then so I want to know what is the tooth growth data, and this is already, the R knows that already. See, what is tooth growth? It says this is the data, the effect of vitamin C on tooth growth in guinea pigs. Okay, so what is that description of that data is, the response is the length of odontoblast cell responsible to tooth growth in 60 guinea pigs. Each animal received one of the 3 doses level of vitamin C. That is 0.5, 1 and 2 milligram per day by one of the 2 delivery methods, orange juice or ascorbic acid or ascorbic acid. So there are 2 types of 2 methods. They are administering the vitamin C. Okay, and then there are 3 types of levels. Okay, 3 types of doses. So I want to know what is that tooth, how does the tooth growth data look like. Okay, so I did X equals tooth growth. Okay, and then I just type X. Let me run that X. So this is the data that it is stored already in our library. Okay, what that means. So vitamin C, dose is 0.5 vitamin C. Okay, through vitamin C, and the length was 4.2. Dose is 0.5 vitamin C. Another is so 11.5. So there are different. So how many? So there are 10 mouse. They are provided vitamin C through a 0.5 milligram per day. Okay, and then see another 10 people got 1 milligram per day vitamin C through the vitamin C, and there are for orange juice as well, the same thing for the orange juice. Okay, this is the data set. So this data set, we did not type this, it is already saved in the library. Okay, now so what we want to do here is, so from Y you can do, instead of tooth growth you can do X here. Okay, because we already said that X is the tooth growth. Instead of tooth growth I want to do just X. Let's see that. So what I'm doing is, look at this, it is called data.frame, meaning that I want to create another data. So this is kind of matrix, right? Because there are like how many rows? There are 60 rows and then 1, 2, 3 columns, right? It is kind of matrix data, right? Now I want to create another data set from this data, but I don't want this the second column. I want to report just, I want to output just the first column and the third column only. How do I do that? Is you do Y equals to data.frame x1, means this is the X matrix, this is the X data. I'm picking the first and then X blank comma 1 and then comma X blank comma 3. That I'm picking just the first and third. Okay, and then I'm giving the column names as length and dose. So see, there was length and dose here. I'm renaming it how? Column names of Y equals to C. Write down C if there are more than one. If there is just one, you need to write C. And then inside the quotation, length quotation, and then comma dose quotation. Because first column has length name and the third column has dose. So if I run this, let me do Y and then do that. So length is Y1, right? See, Y sub 1 is length and dose is basically Y, and then Y and then blank comma 1 inside the bracket, and then so this. So actually, you know, so what I did here is I defined length as the first column and the dose as the second column here. Okay, now I want to plot dose comma length. See, this is what the plot look like. For the 0.5 dose, these are the values. For 1 dose, these are the values. For 2 days, these are the length. Okay, length of the what did they say? I think they said this is the cell or something. Anyway, so this is the length and this is the doses. Okay, now so I want to write this in the table form. Okay, how does the table look like? So the table is 0.5. There are 20 for one dose for 20, and for dose 2 there are 20 as well. Now I want to do the bar plot for this. Say all of them are 20, 20, and 20. So that's what the bar plot look like. Okay. Okay, so there are many data sets that are already stored and saved or saved in the R. Okay, so to find out the list of the data set, what you do is you do data and then parentheses. Okay, so what you here, let's run that data and parentheses. It will give you the list of all the data that is saved here. Okay, for example, air passengers, BJ sales dot lead, BOD, COD, all those. Let us see what is the cheek weight data stands for. Okay, so what I want to do is I want to type what is cheek weight. So okay, so let me erase that and then do what is cheek weights. Okay, let us do that. So it says that weight versus age of chickens on different diets. Okay, the chick weights data frame has 578 rows and 4 columns from an experiment on the effect of diet on early growth of chicks. Okay, that's the name of the data set, and there are objects. These are the objects. Okay, and then weight is the numeric, time is the numeric vector, chick is the an order factor with levels 18 through 48 giving a unique identifier. So these are the number, right? First chick, second chick, and so on, it says. And diet are there are 4 factors for the diet, okay, and all the details are given here. So now let us find out what is that chick weight means here, okay. So what data is that I am doing? Let's hit enter. So this is the data, given data there. For the chick weights, it is given. So it was saying that there are 578 rows and 4 columns. I see the 4 columns there, but the rows are missing because we don't want to see all those data there, okay. So what we are doing is we are just listing only first few. There are 328. The first 250 are listed here, but last 228 you can I'm not listing here, but you can list if you want to. All right, so here let's see, load the dataset chick weight. We loaded that, okay. So I did m equals to let me do that. Instead of writing chick weight all the time, I'm just giving a name m, okay. So you do that, all right, and m is that dataset. So I don't want to write that, I mean the output that dataset again. So let's see, the body weights of chicks were measured at birth and every second day thereafter until day 20, okay. They were also measured on day 21. There were 4 groups on chicks on the different protein diets, okay. Let's see what does it say. So weight, time, chick, and then diet. There are different protein diets there. Construct a matrix G with chick weight, time, and diet only. So you don't want to do chick here, you want to do weight, time, and diet only. How do you do that? So here if you want to do that, then matrix G is like, you write like G equals to data.frame, right? And then what do you do? M, you want to, this is matrix M, right? I want to do the first, second, and then fourth only, right? M and a bracket, comma 1, right? And then M, and then again bracket, comma 2, and you want to skip the third one and then write M and then bracket, comma 4, right? So that's what you do. And then run that. So run it. So it is not showing any error. If there is an error, it will show some error. And then let's type G there and then run that. Okay, that's what G is, because see, look at that. So G is missing the third column of the matrix M. So it is just doing M1, M2, and M4 only. Now I want to keep the name of these because this is saying 1, 2, and 4. So how do I do that? Is you do column names, call names of G equals to C, and then write inside the quotation mark what is the first. The first column name must be weight, right? Let's do weight, 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 and then go to the next quotation mark. The other what is the other one? Time, right? Time, and then the last one, the fourth one has died. So I'm doing the quotation mark died, okay, and then do the quotation mark again here, okay. So that's what you get there. And then I want to type G and then see the G if it changes the name of the column, okay guys. So look at this. So it says weight, time, diet, okay. Now one of the things that I wanted to show you is, let's do like head and then G. What does it do? It just give you the first 5 or 6 rows only, okay. And if you want to see more rows, n equals to let's say 10, then you can see that it will output, the output will have first 10 rows, okay. So if you want to see the last one, you can do tail and then G and then 10. It will show you the last 10, just n equals 10 or just 10. It will give you the last 10 rows or rows of the data set, okay, of that. All right, so this is how you can pick a certain column or certain rows, certain column of a matrix of the data set that has more than 1 columns, okay. So in the homework problem, you will see how do we change a time series data into the normal matrix data like this, okay. In the time series data, usually you cannot basically pick a column, Okay, so you will have to do some more work. I have given the hints in the homework problem. So the time series data, for example, I can give you one example. So for example, let's say m deaths. M death is a data set that is stored already in R. Okay, see, look at this. So what is it doing is it is basically recording. This is the data set for the number of male deaths. M death is number of male deaths. Okay, number of male deaths in a certain place in 1974. This is the monthly death rate, so monthly dates. Okay, so January 2134, February 1863. These are the number of deaths by flu or certain disease in a certain location. In 1975, this is the data. So this data is already stored. But look at this. This data, if you type, for example, class of, let me write down, let's say A equals to, okay, so that you don't have to type M that again. So A is the new name you gave. So how about class of A? If you do class of A, it says TS. TS means the time series data. In the time series data, you cannot pick only one column. For example, if you do, let's say B equals to data.frame, and then if you do A and then the first column like this, okay, let's see what it does. Okay, in the B, I just wanted to pick the first column. See, previously we were able to pick first column, second column, third column, whatever column we wanted to pick, but here we cannot, because the reason is this is the time series data. Okay, in the homework, see the homework for how to change time series data into regular matrix data. Okay, see the homework for that. So we can just change this into regular matrix data, and then we can pick anything you want to here. Okay guys, so we are almost at the end of this video, where we learn about how to get the built-in or the already stored data from R. Okay, and how to generate random numbers from a normal distribution, how to plot them, how to draw a histogram, how to draw a scatter plot, how to draw a bar plot, or the bar diagram, or bar plot or histogram, they are the same thing here, right? Also how to draw a pie chart. That's what we learned. And how to know what is the class of the data. Is it a numerical data? It is a categorical data? It is a time series data? There are many types of data available, data that are stores. Okay, now at the end I want to show you something, that is, if you want to plot more than one plot in the same window, more than one graph or more than one plot in a single plot, how do you do that? So this is the code you use. Okay, we write par and parenthesis mf row equals to c. 2 by 2 means it will plot 2 plot on the top and 2 plot on the bottom. Okay, that's what it does. All right, so if you do plot x versus y, this is the first plot you see, and plot dose versus length, this is the second plot from above, because I did not remove this x, y, dose, length, so it is saving from above. And the another is the bar plot for the frequency distribution table for the what was that, absolute frequency. I think this was D tab. What was that D tab thing? D tab was, I guess this is one, right? So a random number generator, and it is picking, we are basically flipping a dice 100 times, right? Picking a number between 1 and 6 randomly 100 times. That's what the plot is. And the last one was, let us say x is that and name is that, and then bar plot. So this is how we can plot many plots into a single plot. Okay, so the idea is par, and then inside the parenthesis mf row equals to c. If you do 2 times 3, that will be 2 rows and 3 columns. If you do 3 times 2, it will show 3 rows and 2 columns, and so on. Okay, so this is how we do the multiple plots. Okay guys, all right, thank you very much.